Have you heard of Comet 3I Atlas? Tonight, let your body relax and your mind drift through the galaxy, because we're going to learn about this mysterious star that you might not expect. 3 Atlas is unlike anything we have ever seen, deeply and disturbingly unlike it, because when astronomers pointed their instruments at it, they found things that simply should not be there, things that defied the rules of how the universe is supposed to work. Today, we are going to break down what they discovered, why it matters, and what future observations might tell us. Let us step into the mystery. The first clue came from chemistry. Normally, a comet releases water vapor, carbon dioxide, carbon monoxide, maybe even methane. Those are the usual suspects. Simple frozen gases that vaporize when sunlight starts warming the icy core. That is the standard script. That is what comets do. But 3 Atlas did not follow the rules. Instead, the sensors picked up nickel, not just any nickel mixed with iron like we see in nature. No, this was nickel tetracarbonyl, a refined compound, a gas so rare that here on Earth it only shows up in industrial settings, things like aerospace coatings and advanced metallurgy. Finding that kind of molecule around a natural object in space is unheard of. Now, do you feel it? That little chill up your spine? I did when I first saw the data. Nickel tetracarbonyl is a signature of metalworking, a byproduct of deliberate processing. You do not get it in nature, not in that concentration. And yet there it was, streaming out of something that came from another star system. The second clue was physical. Comets have tails that always point away from the sunday. That is basic solar wind physics. The charged particles from our star push gas and dust outward, forming that classic glowing tail. But 3 Atlas broke that rule. Astronomers watched, stunned, as it produced a jet aimed straight toward the sun, fighting against the flow like a river running uphill. Multiple instruments confirmed it, cross-checked, and verified. It was not a glitch, it was happening. So how, why, what force could possibly drive that kind of reversal? And then came the third clue. The chemical ratios in 3 Atlas, the balance between carbon dioxide and water vapor, were not just off, they were extreme. The comet was breathing out CO2 in proportions completely alien compared to anything we have seen nearby, as if it was formed somewhere where water was scarce and carbon dioxide was the main ice. And layered on top of all that was the strangest finding of all extreme negative polarization. It sounds dry, I know, but it means something remarkable. The way light reflected off the surface did not behave like normal comet light. It hinted at textures that were unfamiliar, maybe metallic, maybe something even stranger. So here we stand, feeling a bit dizzy in the vastness of space, a traveler from another star, a comet maybe, but one that refuses to act like a comet. Nickel where no nickel should be. A jet that challenges the sun itself. Chemistry that speaks of alien places. Optics that bend the rules. And behind all that, silence. Because the most detailed close-up images, the ones taken by high-resolution instruments aboard Mars orbiters, still have not been released. They sit somewhere on servers, waiting behind layers of red tape and administrative holdups. And that delay, it gets under your skin, does it not? It makes you wonder what is being held back, what is not being said. That is the heart of the mystery. 3 Atlas is only the third confirmed interstellar object ever detected passing through our solar system. The first was Oumuamua in 2017, a cigar-shaped rock tumbling through space, sparking debate over whether it was natural or something more. The second, Borisov, looked more like a normal comet, icy, diffuse, wild. But 3 Atlas has stepped onto the stage like a phantom, refusing to follow the script, dropping clues that tease us toward conclusions we should not even consider. Some say it is natural, rare, strange, but explainable. Others lean in and whisper, what if it is not? And that is what we are here to explore. To move carefully, one step at a time, through the evidence, to examine the oddities, the nickel, the sunward jet, the strange polarization, and ask what they are trying to tell us, to balance awe with skepticism, to welcome the daring possibilities while honoring the grounded ones, to keep our minds open as we listen to what this visitor might be teaching us about the universe. Because no matter where it leads, whether 3 Atlas turns out to be an unusual comet or the first real hint of intelligence beyond Earth, it has already changed how we think, how we question, and how we watch the night sky. And that is the heart of this journey. So let us begin. Let us look at the evidence. Let us trace the nickel signature and the impossible jet and see where they take us. Because something extraordinary is happening above your head right now. And if we blink, if we look away too soon, we could miss one of the most profound discoveries in the story of science. The discovery, the evidence, picture this. A telescope dome opens in the desert, its metal ribs catching the faint light of dawn. The air is still, the sky endless. And somewhere out there, across that ocean of blackness, hangs a tiny point of light, moving just slightly differently from the others. That is how 3 Atlas revealed itself. A whisper in the data, a single dot that refused to follow the steady rhythm of local stars and planets. At first, nothing more than a curiosity, a faint streak on a CCD sensor. But when its orbit was mapped, the truth hit like a revelation. This was no ordinary traveler. Its path was not bound to the Sunday. It came from beyond. Another interstellar visitor, the third in human history. You could stop the story there and it would still be extraordinary. 3 interstellar objects in just a few years after centuries of silence. It would mean the galaxy is alive with fragments, broken pieces of other worlds drifting like cosmic debris between stars. But 3 Atlas did not stop at being merely extraordinary. Because as soon as astronomers pointed their spectrographs, their polarimeters, the thermal sensors toward it, the universe began to whisper something stranger, chemical anomaly. The first hints came from chemistry. You expect to see water vapor. You expect carbon dioxide, maybe carbon monoxide. But 3 Atlas was different. The signal rising from its surface was nickel, not in raw metallic form, not bound in rock, but as nickel tetracarbonyl. If that sounds unfamiliar, most people never hear the term. On Earth, it exists almost only inside metallurgy labs, a byproduct of refining nickel with carbon monoxide. It is a fragile and toxic gas, unnatural in abundance and industrial in origin. And yet there it was, flowing into space from the heart of an interstellar comet. How do you make sense of that? Could it be the strange chemistry of some distant frozen world? A coincidence? Or something beyond coincidence? Take a moment with that. Nickel tetracarbonyl is the kind of molecule that makes your instincts whisper. This does not just happen physical anomaly, but it was not just the chemistry. The comet itself refused to behave. Comets grow tails when sunlight heats them, releasing gas and dust. Those tails always point away from the sun, shaped by the solar wind. Always. That is one of the few rules you can count on in planetary science. But 3 Atlas broke that rule. Instead of trailing behind, it fired a jet straight toward the Sunday, a reversal, a defiance of physics, like smoke falling downward, like rain rising upward. And it was not a single odd reading. Independent teams saw it too. Different instruments confirmed the same event. A jet that should not exist, moving where it should not go. What could make that happen? Some strange dust structure, electric fields we do not yet understand. Or, if we dare to wonder, something mechanical. It is a question that keeps you awake at night, staring into the dark. Compositional anomaly. Then came the ratios. Every comet carries a story in its chemistry. Measure the gases and you can tell where it was born, what kind of nursery shaped it. Comets from our solar system are rich in water ice with traces of carbon dioxide. But 3 Atlas was not like them. Its CO2 to H2O ratio was extreme, far higher than anything we have ever seen. It was as if this object had formed not in a region rich with water, but in a place where carbon dioxide ruled as the primary ice. A different chemistry, a different origin story. Like tasting wine from a vineyard on the far side of the galaxy. The flavor was alien, sharp, almost unrecognizable. Then came the light. Astronomers do not just study how bright a comet is, but how its light scatters, how it polarizes. It is like running your fingers across a surface to sense if it is smooth or rough. 3 Atlas produced what scientists call extreme negative polarization. In simple terms, light acted in ways it should not. As if the surface of this object was structured, textured, or reflective in a way we have never seen. Was it strange dust? Was it metallic? Was it something built? The data offered no answers, only questions. A cliffhanger written in photons. And just when the mystery reached its peak, came frustration. Spacecraft orbiting Mars, the high-rise cameras aboard the Mars Reconnaissance Orbiter, managed to capture close-up images of 3 Atlas as it passed near the planet's path. Images that could have ended debates, silenced the noise, shown us the truth in crystal clarity, but those images remain unseen. Not because they failed, not because they never existed, but because of delays, bureaucracy, funding gaps, and institutional gridlock. So the most detailed pictures of an interstellar visitor humanity has ever taken sit locked away, unseen by the public. That silence feeds suspicion. It scratches at curiosity. It opens the door for every theory, from the cautious to the wild. So what do we have? A comet releasing purified nickel, a jet spraying against the flow, a chemistry unlike anything in our solar system, light behaving in impossible ways, images withheld. Is it any surprise that scientists are whispering, debating, pacing through hallways, writing papers deep into the night? Is it any surprise the internet hums with speculation, with jokes, with theories about aliens and impossible machines? This is not a neat discovery to file away and forget. This is messy. This is alive. This is science in its raw form, tangled in uncertainty, standing right at the edge of the unknown. And that is what makes it thrilling. Because the evidence, strange as it is only the beginning. What truly matters is what comes next. The theories, the debates, the tension between natural but exotic explanations, and the daring whispers of technology. And that is where the path now leads. You can feel it in the air. The tension, the quiet arguments across conference halls, the long late-night calls between researchers scattered across the globe. Because 3 Atlas is not just another rock drifting through the void. It demands explanation. And those explanations, well, they are proving slippery. The core problem, the heart of it all, is nickel tetracarbonyl. It sounds harmless, almost dull, but if you have ever worked with it, you know it is toxic, fragile, industrial, and it does not form naturally in large quantities. This is not the familiar iron-nickel blend we find in meteorites. This is purified nickel gas, something that on Earth requires furnaces and human hands. So how do we explain it, streaming into the solar wind from an object born between the stars? That is the puzzle. The splinter in the mind of science. It does not fit. And when something does not fit, we face 2 options. We expand the science, or we dare to consider the unthinkable. Theory 1, the natural exotic origin. The cautious scientists begin here. They remind us that the universe is often stranger than we allow ourselves to imagine. Perhaps 3. Atlas was born in a cradle of worlds, nothing like our own. Picture a planetary system where the CO2 ice line, that invisible boundary marking where carbon dioxide freezes, sits in a strange and unfamiliar place. Imagine grains of nickel bathed in the glow of interstellar radiation, chemistry shifting in ways that push the edges of what we understand. In such a cosmic workshop, perhaps nickel tetracarbonyl could come to life. Unlikely, yes. exotic, absolutely, but not impossible. And that is what science teaches us again and again, that the improbable has a habit of happening when nature writes the script. Now, theory two, the techno-signature, there are always those who lean closer, lower their voices, and ask the question that hums at the edge of curiosity, what if it is not natural? Enter Avi Loeb, the Harvard astronomer who is never afraid of shaking the table. He was the one who suggested that Oumuamua, our first interstellar visitor, might not have been a rock at all, but a relic of alien engineering, a solar sail gliding between the stars. His idea sent shockwaves through the scientific community. Many brushed it off, some admired his boldness, and now, with 3 Atlas, those whispers are back. Nickel tetracarbonyl, Loeb notes, is not random chemistry. It is the fingerprint of refinement, the residue of industry. And that sunward jet, he suggests it might come from designed surfaces interacting with sunlight in ways beyond our models. He does not claim it is alien. He only insists we stay honest with our curiosity, that science demands we do not look away simply because the truth might make us uncomfortable. To drive his point home, he dares to give it a number, a probability, maybe 10%, maybe higher, that what we are seeing is not a child of nature. And that number lingers in the mind, because even if it is small, even if it is unlikely, the weight of its possibility is enormous. But science does not survive on daring alone. It endures through discipline. For every bold hypothesis, there must be restraint. Extraordinary claims require extraordinary evidence. That is the rule. You do not rewrite the cosmic story without proof that is undeniable. And right now, the evidence is strange, yes, but is it enough? Nickel could have exotic origins. Jets could have exotic physics. Polarization could come from exotic dust. And so the cautious voices remind us it may look like a techno-signature, but the universe has fooled us before. The safer path is to assume that nature is simply stranger than we ever imagined, deepening the mystery, the sunward jet. Still, the anomalies keep piling up. That jet, that impossible stream of matter pushing toward the sun, it refuses to leave our thoughts. Some propose that the dust itself is the trick. Maybe it is structured in strange, sponge-like ways, scattering light oddly, creating an illusion of direction. Others talk about electrostatic forces, uncharted physics, but none of it fits quite right. The explanations stretch thin, awkward, like clothes that were never tailored for the truth. Each new idea is met with another question. Why nickel? Why that ratio of gases? Why this signature of light? Why? The debate unfolds. On one side stand the skeptics, grounded in the belief that nature, while bizarre, can still surprise us. They remind us that history is filled with cosmic puzzles that turned out not to be aliens at all. Pulsars, for example, were once nicknamed LGM, little green men, until we learned they were neutron stars spinning at incredible speeds. On the other side are the provocateurs. They argue that the data is too odd, the coincidences too many, and that refusing to even consider a technological origin is not prudence, it is fear. To deny the alien hypothesis outright, they say, is to deny the full scope of what science can ask. And in between them stands the public, watching, listening, hungry for answers. This is where the tension sharpens, because we do not know, not yet. Theories swirl, papers circulate, podcasts buzz with speculation, but the key, the truth that could decide it all, is still locked away. Those close flyby images, the ones sharp enough to reveal the surface pixel by pixel, still sit unseen. What do they show? Cracked ice, metallic gleam, geometric symmetry, or just another rock? Strange but natural. Until we see them, the debate burns on. And that is the pulse of science itself, the restless fire that drives us to keep asking. 3, Because for once, in a world that often feels predictable, mapped out, explained to the point of boredom, here is something that pushes back. Something raw, unfamiliar, and deeply unsettling. Whether it turns out to be natural or artificial, comet or craft, does not matter for now. What matters is that it has our full attention, it grabs hold of our curiosity and refuses to let go. It reminds us, with cosmic humility, just how little we truly know. And that, my friends, is the most human realization of all. Think about it for a moment. We are staring at a single interstellar visitor, one frozen wanderer, drifting into our solar system. And already, it is forcing us to rethink what we thought we understood about how planets are formed, how chemistry evolves between the stars, and maybe even how life might travel across the galaxy. That is the quiet but undeniable power of 3IA Atlas. It is not just an object. It is a mirror, a question, a dare, a reminder that the universe does not owe us simplicity. It refuses to fit neatly into our tidy equations or comfortable models. It challenges planetary science itself. Let us start with chemistry. For decades, we believed that heavy metals like nickel and iron were cosmic siblings, born together in the violent deaths of stars, mixed evenly in stellar nurseries, locked side by side inside asteroids, planets and comets. They are supposed to be inseparable, but now here is 3I Atlas, venting nickel gas with no iron, like smoke with no fire, like magic without a trick. The models begin to creak under the weight of this contradiction. Did we misunderstand the way elements sorted themselves in the early days of planetary formation? Could there be exotic environments far from our sun where nature refines or separates matter in ways we never imagined? If it is natural, textbooks will have to change. If it is not, the questions grow even deeper. The pattern of diversity expands, and 3I Atlas is not alone. It joins a small but growing cosmic family. Oumuamua, in 2017, that long, mysterious shape tumbling and accelerating for reasons no one could quite explain. 2 Iberisov in 2019, looking more like a regular comet but brighter, dustier, with its own oddities, and now Atlas, shining with its nickel breath and a jet that seems to defy gravity's rules. 3 travelers, 3 riddles, each breaking the mold. The message is clear. The galaxy is not a place of sameness. It is a vast workshop of diversity. Every interstellar visitor carries a story of its own, a fossil from another star system, a messenger from a distant birthplace. Together, they whisper of countless others, still unseen, each holding its own secrets of alien chemistry, alien motion, alien history. If we are wise, we will not see them as curiosities, but as the birth of a new branch of astronomy. Not exceptions, but beginnings. Yet here is the truth. We almost missed them. Oumuamua slipped by before anyone could prepare. Borisov barely caught our attention in time. Atlas is brighter, easier to track, but still demands rapid action. Scientists are realizing our old methods are too slow. We cannot rely on luck or wait for surveys to stumble upon these travelers. We will need new eyes on the sky, networks of telescopes watching constantly, artificial intelligence ready to spot faint intruders the moment they appear. Instruments ready to turn, to analyze, to chase, all within hours. Because when something like Atlas comes calling, there are no second chances. You either catch it or it is gone. That urgency is already shaping the future. The Vera Rubin Observatory, soon to begin operations, will scan the entire southern sky every few nights, mapping faint glimmers and streaks. It could find dozens of interstellar visitors every year. Imagine that. Not one every few years, but dozens, maybe hundreds, over a lifetime. A growing archive of alien fragments drifting into our reach, each one a page in the story of the galaxy. But for now, the real suspense lies in the months ahead, because as I speak, the data waits, still unseen, still locked away. NASA's high-rise camera aboard the Mars Reconnaissance Orbiter had a perfect view as Atlas passed by Mars. That instrument can detect objects the size of a table on the Martian surface. From that distance, the core of Atlas should be visible in remarkable detail. Not a blur, but structure, texture. Those images, when they finally emerge, could settle the debate. Rock or metal, smooth or fractured, natural or something else entirely. Then comes November and December, when Atlas will rise from the shadows. Telescopes will aim their glass eyes toward it with anticipation. Will it flare brighter? Will it break apart? Will its strange chemistry come alive under the heat of the sun? And beyond that, the Vera Rubin Observatory waits. Once it begins its grand sky survey, everything changes. Interstellar visitors will no longer be once-in-a-lifetime events. They will become familiar guests, logged, analyzed, expected, and if Atlas has taught us anything, it is that each one carries its own surprises. A new standard for discovery, even if, in the end, Atlas turns out to be natural, just a rare comet with unusual chemistry, it has already done its work. It has become a marker, a shift in our understanding, because it has pushed scientists to refine their tools, to test their assumptions, and to brace for the tidal wave of discoveries waiting ahead. And it has pushed all of us, scientists and dreamers alike, to stand in that beautiful tension between what we know and what we do not. That is the realm where science breathes. But here is the deeper truth. 3 Atlas is not just about chemistry or jets or strange data points. It is about perspective. It is about standing on this tiny blue world and realizing that fragments from alien suns are drifting into our neighborhood, bringing with them whispers of other worlds and other beginnings. It is about remembering with humility that the cosmos has not run out of surprises, that even after centuries of study, the universe still has ways to make us question, to make us wonder, to make us dream. And in that dream lies the promise of what comes next. A future where every interstellar object is a messenger. A future where telescopes do more than observe. Where someday our spacecraft might meet these travelers, land on them, sample them, bring a piece of another star system home. Imagine holding in your hand a fragment born under a distant sun, the geology of another world resting in your palm, the past of another system heavy in your grasp. That is what 3 Atlas hints at. That is why it matters. And so as debate continues, as data flows in, as whispers of the extraordinary brush against the careful discipline of science, one thing is already clear: 3 Atlas has changed us. It has reminded us that certainty is fragile and mystery is vast. It has shown us that discovery is not a straight path, but a dance between anomaly and understanding. It has reignited something precious within us, that ancient human feeling of awe. And awe is where wisdom begins. So here we are, after weeks of speculation, after nights spent watching data stream across screens, after discussions that stretch from quiet laboratories to wild corners of the internet, left with a comet, or perhaps not a comet, that refuses every box we try to fit it in. Nickel without iron. A jet that dares to challenge the Sunday. An object so rich in carbon dioxide and so poor in water that it feels less like a sibling of our comets and more like a stranger from a family we have never met. Let us strip it to its essentials. Atlas gives us 3 riddles. The first, metal in its breath, nickel. Not the rough kind mined from stone, but purified into nickel tetracarbonyl, a compound so unnatural that here on Earth it exists only inside factories. The second, its defiance of sunlight. Instead of trailing dust away from the sun, Atlas throws a jet straight toward it, a torch burning against the current of physics. The third, its alien chemistry, a comet ruled not by water vapor but by carbon dioxide, an inversion of every frozen wanderer we have ever studied. Each puzzle alone would be strange. Together, they form something deeper, something that does not shout but quietly insists, look again, look closer. And so the debate sharpens. The naturalists say maybe Atlas was born in some forgotten region of its home system, a place where chemistry went wild, where carbon dioxide froze thick and water was rare, where radiation sculpted its surface into something unique. Unlikely, they admit, but the universe never promised us normal. The dreamers say, maybe this is no coincidence. Maybe what we are witnessing is not natural at all, but a relic, a fragment, a sign. And between those voices, the cautious ones repeat the oldest mantra in science. Extraordinary claims require extraordinary evidence. The truth is we do not have it yet. But we also do not have the opposite. And that is why 3 Atlas exists in that beautiful tension between possibility and proof. That is why it matters. But here's the point. Even if it turns out to be natural, even if every anomaly fades under new data, it has already achieved something remarkable. It has reminded us that science is not a solo act. It is a conversation between the known and the unknown, between data and imagination, between what we predict and what the cosmos actually delivers. Atlas has pushed planetary scientists to rewrite chemical assumptions. It has pushed observers to design faster, more adaptable systems of detection. It has pushed philosophers and dreamers to look up and wonder if we might be seeing something constructed rather than formed. And in doing so, it has pulled all of us closer to the raw edge of curiosity, the waiting horizon. There is more ahead. The story is still unfolding. In the coming months, the delayed high-resolution images might finally appear. If they do, they could strip away the blur and reveal the nucleus itself, its structure, its texture, its truth. The Vera Rubin Observatory will awaken soon, its vast digital eye sweeping across the heavens, catching the faint whispers of interstellar visitors that might have slipped past unseen. And Atlas itself will return from behind the sun, revealing what the heat has done to it. Will it flare apart into fragments? Will it fade into quiet? Will its strange jets grow stronger? We will find out soon enough. But for now, in this brief pause before the next revelation, it is enough to stand in awe of what has already been shown. And perhaps that is the real lesson, not just about Atlas, but about us. We are a species that refuses to stop asking. We look at a dim smear in the sky, and instead of turning away, we point our most powerful instruments at it. We debate it, we argue, we dream, we fill the silence of space with our questions, our fears, our hopes. And whether Atlas proves to be natural or not, it has already fulfilled its mission. It has made us think bigger, wider, deeper. It has reminded us that the universe is not a solved equation, but a living riddle. So picture this. It is late at night, the world sleeps, you step outside and above you, the sky clears. Somewhere out there, fainter than faint, drifts Atlas, a messenger from a star we have never known, carrying secrets older than Earth itself. Secrets that have crossed light years to reach this very moment. And you realize that you are part of that same story, that the atoms in your blood, the oxygen in your lungs, the iron in your bones, all of it was forged in stars, scattered by explosions, gathered into worlds. Atlas is not separate from you. It is family. And in that realization, the line between science and poetry disappears. That is why we watch. That is why we listen. That is why we chase these stories into the dark. Because whether it is a comet, an artifact, or something we have not yet imagined, it reminds us that we belong to the universe, and the universe belongs to us. So keep watching the skies, keep questioning, keep wondering, because the next discovery could change everything we think is possible. And if this mystery stirred something in you, if even for a moment you felt that spark of awe, then come back. Share this. Add your voice to the conversation. Because the cosmos is speaking, and together we can listen